Hey, everybody. Welcome to, oh my gosh, is it week 5 now? Week 5 of the free JavaScript bootcamp. Hope everybody's having a most wonderful day today. Jess sends her best. It's going to be just me today. Everything is cool. We'll be back tomorrow to our usual rhythm. Um, Folks who are watching from the Americas, you might notice that this is running at a different time. After this week, the clocks in Europe will change as well, and then the usual rhythm will be back. So thank you all for bearing with us while this time zone little shakeup takes place. And if you're joining in for the first time, hi, my name's Ramon. Jess and I are running this series of free boot camps. Right now, we're doing the JavaScript one. If you're interested in learning more, please check out our website, Bad Website Club. Just put the link there in the chat. If you want to catch up with the videos, you can go to our YouTube channel, youtube.com/@badwebsiteclub. And by joining this bootcamp, you are agreeing to abide by our code of conduct, bit.ly/BWC-COC. Please make sure that you conform by it. If you see anything out of sorts, just please let us know. Okay, that's enough of my rambling. Let's talk about what we're going to be doing today. Today, we're going to be doing a little bit of algorithms. I'm excited. I know algorithms tend to sound pretty scary, and a lot of the time, they're going to be often things you'll see in job interviews or perhaps in exercises. And while you're probably going to notice that it's, especially as the years go on, that you're not using them as much as you would think, they still lend themselves well to understanding logical processes in complex data structure manipulation or that sort of thing. So in this session, we're going to be doing a number sorter, which will take this series of drop downs and sort their numbers a given way. Now, as Jess said, I'm actually going to be skipping way ahead because a lot of the beginning is stuff that we've done before, and I want to make sure that we focus today on the specific lessons of stuff we want to learn. That is the algorithm itself for sorting. But let's just briefly walk through what we've done in steps 1 through 12. We have our button variable, and we have a function called sort input array, which is a form submission, prevents it from redirecting, and grabs all of the numbers from these drop downs. If you want to dive in and see what specifically this does, I recommend doing so, or we can do it in the Q&A if this is something we'd like. But as said, I'd like to focus on the algorithms today. We also have a function that updates the UI, which is that it takes each of these numbers from our DOM and updates their value according to the sorted array. But we're not doing any sorting yet, and that's because we want to actually start doing that here. But we also have an event listener for clicking on the sort button that sorts that input array. Right now, just updates the values to be the numbers as they are, which is not what we want. We want to start sorting them from lowest to biggest. So let's do that. We're going to create a new function called bubble sort. And you might have heard of bubble sorts before. The bubble sort is one of the, I would say, most commonly learned first sorting algorithms. This is a process that takes an array of values and sorts them from lowest to biggest. And what it does is it takes each of these values and bubbles them to their appropriate place. And we're going to see how that works in just a moment. Hi, everyone. Thank you so much for joining in. Love to see folks coming in and saying hello. So cool. We've got our bubble sort function, and it takes an array as a parameter. So far, so good. Let's pat ourselves on the back, pat, and keep going. So we're going to use a for loop to iterate through our array. I'm going to use a for const, let's call it value of array. And there we go. I hope this is the kind of for loop they want. No, see, they want one with indexes. Fair. So for let I equals 0. I must be bigger than, smaller than array.length, and I will go up by 1 between each step. Cool. Pat, pat. And folks, if I'm going too fast for you, just bear in mind, you can also remember that this is all recorded and you can come back and watch it later. What I would recommend for each of these is to also try to solve some of them on your own and then come back and watch it as well. So we're going to have a for loop inside our for loop, but this should iterate through every element in the array except the last one. So for every element we loop through, we're also going to loop through that same array, but instead of I for our iterator, we're going to use J. That's because we can't have both of them be the same. But we want it to be smaller than array.length. However, we want to loop through every element in the array except the last one. So instead of J being smaller than array.length, we want J to be smaller than array.length minus 1. We'll go to J++. Now, so now we have 2 for loops inside each other. Now you might be wondering, how does that even look? Well, you know what I'm going to do, right? First of all, we pat. Second of all, let's take this for loop inside a for loop, and let's hop over to Python Tutor. Now, the only thing I need is an array. I'm just going to grab some random numbers. Let's have this one be the number 7. And we're going to console log I and j. And I'm going to make this 3 elements just so we don't spend too much time on this. So cool. Oh, actually, give me 1 sec. Eric's saying, hey, I find it annoying to start an exercise almost in the middle. Haven't got a clue what we're doing now or why, but that's only my opinion. I appreciate it, Eric. I'm sorry that my brief walkthrough wasn't valuable. I was kind of hoping that we could start there so we could focus on the core elements. But believe me, we definitely want to streamline this as much as possible for y'all. So here's our array. Now, we start at I being 0, and we go over to j being 0. So because both I and j are 0, when we console log array I and array j, we're going to get the first value twice, 7, 7. Now I is 1. So array I and array j are going to print out 7 and 5. J is now 2, but remember, we're not going to have j go to the last one. So we hop over to our next step in the original for loop. So I is now 1, j is now 0. So we got 5 and 7. And then we'll have 5 and 5. J doesn't go to the last one. Then I is 2, j is 0. So we print out 4 and 7. And then 4 and 5. J doesn't go to the end. And we're at the end of our original for loop. And that's it. So that's how we have nested loops. And I just wanted to take a moment to step us through that. I hope. Oh, yeah, we did do this. Cool. All right. So as you know, this bootcamp is totally free, and so is Free Code Camp. They are a registered nonprofit, and they depend on donations, but only if you want to, only if you can. You can also come back later and donate a little bit if you want, but we're just going to move on and appreciate this very cute animation and click on Ask Me Later. Oh, look at that. Console log array, array j, and array j plus 1. So, of course, we don't. Sean, that's a great point. Maybe a good middle ground would be a heads up in the Discord. I did actually put a little note there, but since I only put up that notice an hour before we started, that wasn't very helpful. My bad. But yeah, we put in this console log. We notice that nothing happens because, of course, we're not calling the bubble sort function. However, if I were to bubble sort, actually, we'll probably do that in the next step, huh? Yeah, let's pat pat. So in our function to do the actual sorting, we will declare a new variable called sorted values, and we'll assign to it the value of input values bubble sorted. And instead of updating the UI with the input values, we will instead update them with sorted values. Now we can see that loop actually going through. And you remember what I said about the nested loop? We can see that taking place. Cool. Let's pat pat and keep going. Now, Sean, no need to apologize. Appreciate the feedback. So in our nested loop now, what we're going to do, and this is how the bubble sort algorithm works. What we're going to do is check for each value in our array how it compares to the one next to it. Stephen B, got your question. We'll definitely do that during Q&A. So we'll create an if condition. We want to check if the current element, the current one being the one at index j, so array j, whoops, is bigger than array j plus 1. Fantastic. So we're checking, hey, is array at position j larger than array at position j plus 1? So is, for example, this value bigger than this value? But what happens then? What we want to do is, if it is, we want to swap them over. So what we'll do is we'll declare a temporary variable, and assign to it the value of array at position j. Then we'll set array at position j in order to swap them, right? To be equals to the member at j plus 1 and the member at j plus 1 is now equals to array at j. Now this looks complicated, so I'll tell you what we'll do. I want to try this out in Python Tutor and see how it looks. I'm not going to do the if statement. I just want to see what this step looks like. What does swapping around mean? So we've got our original array here, and let's just do this here. Now, let's have a variable called j and set it to be 0. Now let's take a look at what happens. So our array is 7, 5, and 4. Our variable j is set to 0. We're assigning the variable temp or temporary to be 7, whatever's at array at j, which is 7. Then we'll set array at j to be the value of array at j plus 1, which we know to be 5. So keep an eye on array. Check out what happens. See? Now the part at 0 is 5, but we still want to swap them. Oh, hold on a sec. I wrote this wrong. This should be temp. No wonder I'm confusing. I'm sorry, folks. Let's go back. So we're here. So temp is 7. Array at position j is array at position j plus 1, which is 5. And we want to set the 1 at position j plus 1 to be temp, which is now 7. So what these 3 lines of code do is exchange the 2 values at those positions in the array. Chris is asking, so j is like index 0 in the array. Correct. Because remember, in our loop, we're going through each member. What I would love to do is once we've finished building this sorting algorithm, that we go and play with it in Python Tutor. Now I need to fix my code here. There we go. Pat, pat. Let's keep going. And once our outer loop, because remember we have an inner loop and an outer loop. So after that outer loop is done, we will return the array, which is now sorted. You might be wondering like, wait, that's it? It's sorted? Well, you don't have to take my word for it. Let's give it a try. So let's keep that original array. Okay. And we will bubble sort. Oh, hold on. Let's call this numbers. Did I forget? Yes. Forgot one of the curly brackets. There we go. Yep, thank you for that. Okay, so we've got our numbers, 7, 5, and 4. Fantastic. So we're going to call bubble sort with this array. So we'll start at I, which is 0, and we'll start at j, which is also 0. It'll console log the array, whatever's at position 0, and whatever's at position 0 plus 1, because remember, array j is 0. So j at 0, and this is j at 1. Is array at 0 bigger than array at 1? Is 7 bigger than 5? Yes, it is. So watch the array. We're going to swap them around as we did in the last step and move on to the next element of j. So j is now 1. Notice we're still on that 7. So is 7 bigger than 4? Yes, it is. So we'll swap them around. Now 7 is at the end. So what we've done is we've taken that 7 and pushed it to the largest place where it belongs. Next one. Now I is 1. Now, the question is, j is 0, remember, right now, j is 0, so we're checking, is 5 bigger than 4? Yes, it is. So we'll swap that 5 and that 4 around. Now, I is 1. Is 5 bigger than 7? No, it's not. So we do not swap them around. Now I is 2. So we'll do that loop one more time. So we're checking. Is 4 bigger than 5? Nope. And again, we're checking. Is 5 bigger than 7? No, it's not. So we're done looping through the j's. And now we're done looping through the i's. And look, our array is now sorted. I would take the time to step through this a couple times and make sure that it clicks. In the meantime, let's check our code, which does not, oh, we need to remove the console log. My bad. Boop. And there we go. Pat, pat. Oh, you know what? I forgot to try it out. Because of course we're already using the bubble sort here. Let's give it a try. So if I click here on sort, 1, 2, 3, 4, and 8. What we're going to be doing next is a different algorithm for sorting. This one's called the selection sort. The way it works is by finding the smallest value in the array and then putting it at the earliest position. Then it finds the next smallest value and swaps it to the second position. And it keeps doing that until it's swapped all of them. So let's make a selection sort variable and make it a function just like with the bubble sort. Good to go. Pat, pat. Now, instead of using the bubble sort, we're going to start using the selection sort. Cool. Pat, pat. That's an easy one. Now, we will need a for loop. On this time, we know to make it one of these. I love Stephen B's advice of using very descriptive console log statements. I highly recommend doing this. Array.length I plus plus. Oops. So there's our for loop. Cool. I'm feeling pretty good about that. So what we're going to do, remember, is to go through the entire array and find the smallest one. We're going to be doing this by having a variable called min index. Oops. So this is going to be the index of the smallest value in this range of the array. So when we start at 0, we're going to be like, hey, you know what? So far, 8 is the smallest, the index of the smallest value. So once we have that min index, then we're going to declare a nested loop. Same as before. So, however, instead of starting at 0, this loop is going to start at I, which is a little weird, but we're going to Python tutor this. So j has to be smaller than array.length, and j will go up by 1 between each iteration. So this loop will go from 0 to the end of the array. This nested loop will go from whatever position we're at currently in this loop. So from I to the end. So for example, if I is 0, it'll go from 0 to the end. Then I is 1, it'll go from 1 to the end. If I is 2, then it'll go from 2 to the end, and so on and so forth. Oh, wait, at the index after I. Thank you, Jane. Thank you, Jane. Plus 1, plus 1, plus 1, plus 1. The index after I. So if I is 0, j will start at 1. If I is 1, then j will start at 2. If I is 2, then j will start at 3, and so on and so forth. Thank you. Does that look good? It does not. Ah, I made it a const when it should be a let. That's because it's going to be changing. Cool. Let's pat pat. Now, we're going to do the same a very similar console log we did before. We will have the array at position j, and the array value at position minimum index. We can see when we console log now what's going on. So we've got 8, 2, 4, 1, and 3. So the first iteration, and 8, and then 4, and 8, and then 1, and 8, and then 3, and 8. Then we're at the next part of the outer loop. So start with 4 and 2, then 1 and 2, 3 and 2. Then we're at the next iteration of the outer loop, 1 and 4, 3 and 4. Then we're at the next iteration of the outer loop where we just have 3 and 1. Now, I would say that's a bit weird to just go through like that. So how about we go back to Python Tutor, and I'm just going to use my own for loop, my own console log. So I is, I'm seeing some folks saying this is difficult to grasp. Don't worry, none of this is supposed to like land on the first try. I would recommend following along, and if it's not all sinking in immediately, come back, try it out, play around with it in Python Tutor, and then come back to the lesson, see if my jabbering works that time. I is this, array number is array. Just going to go with numbers instead of array. Cool. And we're just going to gently just step through this. For example, I is 0, array number is 7. At the next one, array is still 7, j is still 2. Now I is 1, array is 1, number is 5, and then array is 1, number is 5. Now, remember what we want to do is step through the entire array, start at 0, and find the smallest value. The way we would do that is by checking, hey, is the value at position j smaller than the value at position min index? And if it is, we'll set that min index to j. Now I want to take this whole thing again and step through it in Python Tutor. We're not doing anything yet. We don't have a full grasp of what we're doing here yet. I just want to see what's going on. So selection, sort, numbers. So we're looping from I to the end. Remember, I starts at at 0, which means the minimum index is I, which is 0. Now we're going to loop from 1 to 2. Hey, is array at j, 5, smaller than array at mid index, which is 7? Is 5 smaller than 7? Yes, it is. So the minimum index is now j. Minimum index is now 1. So now we go to the next number. J is now 2. So we're checking, hey, is array at j, which is 4, smaller than array at min index, which is now 1? That value is 5. So is 4 smaller than 5? Yes, it is. Now, just taking that into account, what have we done? We've looped through our array to find the index of the smallest value. And that index is 2. That's all we've done. but we're not going to do anything. Now in the outer loop, we're going to come back to the minimum index being I, which is now 1. And we'll do the same thing. We'll go from 5 to 4 to find the index of the smallest one. Hey, is array at 2 be smaller than array at 1? Is 4 smaller than 5? Yes, it is. So that min index is now 2. We terminate that array, and we do it one more time. The min index is 2. We don't do any looping through j because we're done. And then we're done with our I. But again, we haven't actually done any sorting. We've just found the minimum indexes. But remember the part of that description of what the selection sort is. It's going through the entire array and finding those minimum indexes and moving that number over there, or doing a swap. And that swap is very important because that's what we're going to do next. So we'll pat, and we know what to do about swapping, just like what we did at the bubble sort. So we will take temp, and we will assign to it the value of array at I. Then we'll set array at position I to be array at position min index. And then we'll set array at position min index to be temp. We've performed our swap. So once we found the index of the minimum value, we switch it with what I is. Remember, we're not looping through j anymore. We're in our outer loop. This that's already done. We then swap the values. Let's check our code. So after your nested, you should declare a temp value variable, which I thought I did. They extract the value at I, and then swap the values of I and min index, which I thought I did. After your nested for loop, which I did, you should declare a temp variable, which I did. Array at I, and then we set array I to be array at min index. Oh, you know what? I switched them the way around, didn't I? No, I did it. What am I doing? Let's swap the values at I. Maybe it wants a lent and a const again, huh? Maybe. Let's give it a try. Now, after your nested for loop, you should declare a temp variable. Look, I'll declare a temp variable. I can do that, no problem. Let's just break this down. Array at I. After your nested for loop, you should... Oh, I know what's up. You know what's up, friends? I wrote comments. It's the comments. I keep forgetting that I shouldn't write... Like, usually it's good to write comments in your code, but like... array at I is equals... I'll just write this out again. Array at min index. No, the problem was that I wrote those comments. There we go. Let's see. You should assign temp to array at min index. Okay. Wait, no. And then I should put temp here. There we go. My bad. So not only did I do my swap wrong, I forgot that it doesn't like the comments. There we go. So temp is set to array at I. We set array at I to be at array at min index, and then we set array at min index to be temp. That should be good to go. And once our outer loop is done, we can return the array, and it'll sort it again. But again, I kind of want to step through this with Python Tutor. So let's do that. Thank you all so much for bearing with me. I know that when it gets more abstract like this, it can be really frustrating. So we're starting here. Well, I'm going to need a little bit more space now. There we go. So we've got 7, 5, and 4. So we'll start at 0, which means our min index is 0. Now our duty is to find the min index, the index of the minimum value. So j starts at 0. So j starts at 0 plus 1, which is 1. So remember, min index is still 0. So is 5 smaller than 7? Yes, it is. So the min index is now 1. Next up, Stephen B., I'm going to bookmark that and cower in fear because I would ask you to please maybe clarify that question. Do you mean like sorting five arrays one after the other? Let's come back to it. Okay. So min index is 1. Is 4 smaller than 5? Yes, it is. So min index is now 2. Now, we found our minimum index. Our minimum index is 2. So we're going to swap whatever's at 0 with the minimum index, which is 2. So we're going to swap the 7 and the 4. So temp is assigned the value of 7. 7 is assigned the value of 4. And min index is assigned the value of temp, which is 7. We've swapped 4 and 7. Fantastic. So now we're at the next step of our loop. So I is now 1. So our min index is 1 as well. And now we're going to look for the index of the minimum value from 1 to 2. So the question is 7 smaller than 5? It's not. So we will go to the next one. But there is no next one. Our min index is 1. Now this is where it gets a little bit redundant, as in we're doing stuff that is an extra step that doesn't really need doing. We're swapping I and min index, which if you notice are the same. So the minimum index is 1. We don't need to worry about swapping 1 with itself. So now we'll move on to 2. Min index is 2. We don't sort through anything because there is no other index to look for. So we swap 2 and 2, nothing happens, and we return our sorted array. 4, 5, and 7. Philip R., I'm so glad that it's helping understand. I see some questions. I'm actually going to save them for the Q&A because they're really good questions. And yeah, they're really good questions, folks. Cool. So that's the selection sort. Now, I bet there's probably one more. Oh, we will remove our console log. Fantastic. Pat, pat. Cool. So we're going to do one more sorting algorithm. And I bet some of you are wondering, like, wait, do we need to know all these algorithms? I will answer that during Q&A. So this one is working by building up a sorted array at the beginning of the list. Wait, what? So it begins the sorted array with the first element and then inspects the next element and swaps it backwards into the sorted array until it is in a sorted position and so on. So what it does is looks at a member of the array and goes like, cool, we're here. Everything looks great. Let me look at the next one and put it behind me in such a way so that it's sorted. So for example, we're at 8, we start at 2. 2's like, well, I'm smaller than 8, so I go behind 8. And yeah, we'll see how this works. Let's take our insertion sort variable and it takes a parameter called array. Cool. Pat. Now, we will, instead of using the selection sort, we will now use insertion sort. Fantastic. That's a nice little freebie, pat. Now, what we're assuming here is that our first element is already sorted. So we will have a for loop that starts at the second element. Let I equals 1. So we'll start at the second element, iterate through to the end, and go up by 1, as we've done before. So we've got a variable called cur value. Cur in this case is short for current. So we're going to assign to it not I, but the value at I. Then we'll declare. Tower of Brilliance is asking such a good question that I'm going to save for the Q&A. So declare a J variable and assign to it I minus 1. Our J variable should be reassignable. We know what that means. Not a const, but a let. So we've made two variables, the current value and J, which is I minus 1. Cool. Pat. Now, instead of using a nested for loop, we're going to use a nested while loop. First of all, this will have two conditions. The first one is that it should not run beyond the beginning of the array. That says to me J needs to not be smaller than the beginning of the array. And if J is an index, the smallest index we can have needs to be bigger than or equals to 0. First. The second one, so that's double ampersand, please. There we go. The loop should not run after it finds a value. Let me try this again. The loop should not run after it finds a value smaller than the current value. Oh. Okay. So array at J should be bigger than or equals to cur value. And to prevent an infinite loop, we're going to decrement J minus minus. So cool. J needs to be bigger than 0, and whatever J we're looking at the moment needs to be bigger than the current value. The loop should not run after it finds a value smaller than the current value. That sounds about right, but I don't think FreeCodeCamp agrees. Should have a condition that checks that the value of array J is greater than current value. Maybe it just needs to be greater than? Cool. Pat. My mistake. So on each iteration of our while loop, J is going down by 1. We're finding an element that is larger than the current value. We need to move that element to the right to make room for the current value. Do so by assigning the value at the J index to the next index. This wording is confusing. We'll walk through it together. On each iteration of our while loop, so inside our while loop, we are finding an element that is larger than your current value. We need to move that element to the right to make room for your current value. But if we need to... Oh, wait! We need to swap! We need to move that element to the right. I know how to do this. Const temp equals cur value. Is that right? Wait. No, array at j. Array at j. Then we need to do array j plus 1 is equals to array at j. And then array j needs to be, I'm doing this the way around, aren't I? Needs to be equals to temp, and array at j needs to be equals to, there we go. I'm doing the swamp in reverse. I'm not doing so good today. J plus 1. Did I do that right? Not even close. Assign the value at j to the index j plus 1. Oh, so I'm not even doing a swap. I'm just moving it over to the right. Cool. Okay. Before decrementing j, assign the value at j to the index j plus 1? That doesn't make much sense. Like this? I'm sorry, folks. Sometimes you just get stuck on stuff. Before decrementing j, assign the value at j, which is array at j, to the index j plus 1. So like this. The value. Let's try it your way. Chris. J equals array j plus 1? That doesn't make sense. No. This sounds about right. Array at j. Maybe I need to do like spaces and stuff. Weird. Stephen B, I agree. It's array j equals array j plus 1. Do I need help? Whoa. Whoops. Nope. That was not what I intended. Array at j equals to array j plus 1. For the sake of us not... Wait. Oh my goodness, Stephen B, you're right. See, this is what happens when you don't read properly like I do. Assign the value at j to the index. Oh my goodness. Yes, you're right. It is absolutely the other way around. So we're moving that value to the right. Y'all are too patient with me. You know what? That deserves a little bit of a pat for me, but a big pat for y'all. So after our while loop, we need to insert our current value. Remember that the loop ends when j is either out of the array bounds or when the value j is less than our current value. So we will use the assignment operator to insert our current value into the correct index. So array at position j is equals to current value. Sorry, j plus 1. Okay. And I'm still going to want to Python tutor this at the end. After our outer loop is finished, we can return array. And we can see, okay, cool. This is a little confusing. So I'm with you, Jane. Let's take this insertion sort and just try and make some sense of it. Cool. So we've got our array. Now we're starting at I. That current value is array at I, which is 5. Now, j is going to start at 0. So while j is bigger than 0, bigger than or equals to 0, and array at j, which remember is I, is bigger than current value. So current value is 5. Is array at j bigger than 5? Yeah, because 7 is bigger than 5. So we're going to move that value to the right. So array at j plus 1 is equals to array at j. So keep an eye on the array. See? It moved to the right. That's 7 moved to the right. J goes down by 1, so j is now -1. Well, j is no longer bigger than or equals to 0. So we're done. And array at j plus 1, -1 plus 1 is 0, is a current value, which is 5. Now I is 1. Sorry, I is 2. Our current value is 4. J is equals to 1. Is j bigger than or equals to 0? Yes. Is 7 bigger than 4? Yes. So what we will do is we will move that 7 to the right and go down by 1. Now, is j bigger than 0? Yes. Bigger than or equals to. Is 5 bigger than 4? Yes. So we will move that 5 over to the right. Now you see what we're doing? We're just like moving everything over by 1. And then once we're done, we plop that 4 at the beginning. Now our array is sorted. So what we're doing is going through each number and move everything else over into the right so that we can plop that number where it belongs. So that's the insertion sort. Now, I know that this is very mean of me, but we're going to stop here. I would love to invite the rest, I would love to invite you as a homework to step through the rest of these. And I think all you need to do is work with that sort function. Now, there's a couple of questions that y'all have been asking that are really, really valid. So I'd love to take some time to step through these. And also, I want to see if I can find some animations of sorting algorithms. So first thing we're going to do is bring up those questions. First off, oh yeah, can we go through step 7, specific where map is getting those values from? Let's do that. So step 7. Those values are strings and we need them to be numbers. Since we have an array, we can use the map method to convert each value to a number. So we have that array of values from the dropdowns. We're using map to take each of those strings and return the dropdown value. So don't take my word for it. Let's console log this. So we've got a series of elements, right? What we can do is map from them, drop down, just their drop down value. Let's look at it again. Did I do it wrong? I might have. I think I'm missing a, yep, there it is, missing a parenthesis. Sorry. So we're getting all of the elements that have the class values drop down, which are these ones here. That gives us an array of elements. We can use map with a callback to create a new array from those values. I am so sorry. I just saw the comment. So we're taking an array of elements that have this class, which are these ones here. And remember that element, which is a dropdown, has a value. It's not a key value pair, Stephen P. It's an element. It's an array of elements. And because we know that these are dropdowns, we know that we can get their values. Check it out. When I set this to 3, that's my one there. So all I'm doing is using map to get that array of values. What I'm then using number for is to turn them into numbers, because right now these are strings. Oh, hold on. I put that in the wrong place. Sorry. These drop-down values are strings. You know how I know they're strings? Because in our HTML, we're using quote marks for those values. So we're turning them from strings into numbers. Mehmet's asking array.from. Does this do the same thing? I mean, you don't have to ask me. Let's ask the computer. Yep, does the same thing. So Chris is asking, what does the spread operator do here? Let me just go back to what it was before. Remember, the spread element lets us make a copy of each element in that array. I think we covered the spread operator a few lessons back. I would say go back and play with it. But yes, it's making a copy of each element of that array, essentially making a fresh array. I hope that's helpful. It's a lot. Stephen B., I'm going to leave your grid of arrays questions real quick. For a bit, I'm thinking of other exercises using nested loops. Monica's question. Can we use a built-in sort function for this in real life? And this exercise is to understand the underlying concept? Yeah, pretty much. Here, I'll tell you what. Don't take my word for it. 2, 9, 1, 5, sort. So JavaScript has a built-in sorting functionality. And you know what's the best part? I don't know what sorting algorithm it uses, and I don't need to know. It's probably the one that's best for the job. So you might be wondering, why are we learning sorting algorithms? As Tower of Brilliance asks, how do you know which sort would be faster or the right one to use? And this goes into something called algorithmic complexity, or you might have heard of big O notation. I'm not going to go too much into that for this bootcamp. However, the short version is, if you're doing a nested loop, then you have a higher complexity than you would a one loop, like a non-nested loop, just one loop. Now, which one do we want to use that's best? I would recommend just using the built-in sort algorithm when you want to sort numbers. So what would be the benefit of using this backward sort? In terms of efficiency, not a huge one, because at the end of the day, we're still using a nested loop. Oh. Okay. Hold on a sec, folks. Let me bring up something here, and I'll paste it in here as well, in case y'all are interested. Let me hide this comment real quick. I'm just going to go on for a little bit longer. So here we have a bunch of arrays and a bunch of sorting algorithms for them. They're kind of fast, but it shows you how each of these go. For example, let's try the bubble one, which, remember, bubbles a value to the top. See, it finds, oh, sorry, that went with the selection one. See, it's finding the smallest one and moving it to the beginning. Now let's do bubble, which, remember, pushes an element to its rightful place. look at insertion. Remember, it inserts each value to its appropriate place. There's other types of sorting algorithms. I'm not going to mess around with them today. Try these out. Play around with them. For example, let's check out this reversed one. See, it's going through each insertion is going through each of them and putting it in its right place. Selection. Finding the smallest one and moving it to the beginning. Bubble. Bubbling a member to its appropriate place. Play around with these. I'm going to be honest. It's good to know and understand how to follow an algorithm. If you were to ask me tomorrow, how does the insertion sort work? I will not remember. Let that tell you what it will. Okay. I think that answers 2 of those questions. But okay, Stephen B. At the risk of complicating things, I could possibly explain the sorting loops with a grid of arrays, i.e. 5 rows of arrays. Usually when I've used J indexes / indices, it's been when sorting arrays within arrays. And I think that's what Stephen B is talking about. I'm thinking of other exercises using nested loops to iterate through an image file, like so many rows and columns of pixels. I'm still afraid I don't understand the question. I'm so sorry, Stephen B. Let me go back to the chat and see oh, and I suspect there's a way to visually these sort of sorting algorithms. I guess the animations kind of answer that for you, huh? Yeah. Oh, I love this point you're making here, Stephen B. Arrays within arrays triggers a bit of a math fear in me, though, since I never pursued math beyond high school, but seeing that structure of rows and columns of pixels was more approachable. Yeah. Thank you all for your questions. Well, gosh, folks, we had a tough one today. Appreciate you all bearing with me. Tomorrow, we're going to come back. We'll even have a little bit of homework, as said. And tomorrow, we're going to use a statistics calculator to learn array manipulation methods such as map, reduce, and filter. What I'll do is let y'all know ahead of time, even further ahead of time, which step we'll be starting on tomorrow, just to make sure y'all aren't caught off guard. I would recommend, as I do always, just taking a bit of a look at what's coming up, especially when it comes to setting stuff up. Let me just, if I may, poke through real quick. Oh, wow, we're going straight into a calculate function. Maybe we won't start right at the beginning. Maybe we will start right at the beginning. Who knows? Tomorrow will be a 2-parter, though. Yeah. All right, folks, that's me for today. Thank you all so much. And I'll see you tomorrow. Bye for now.